So now we will start the summary for chapter 5 entitled Ethernet. The OSI physical layer provides the means to transport the bits that make up a data link layer frame across the network media. Ethernet is now the predominant LAN technology in the world. Ethernet operates in the data link layer and the physical layer. The Ethernet protocol standards define many aspects of network communication, including frame format, frame size, timing, and encoding. When messages are sent between hosts on an Ethernet network, the host format the messages into the frame layout that is specified by the standards. Because Ethernet is comprised of standards at these lower layers, it may best be understood in reference to the OSI model. The OSI model separates the data link layer functionalities of addressing, framing, and accessing the media from the physical layer standards of the media. Ethernet standards define both the Layer 2 protocols and the Layer 1 technologies. Although Ethernet specifications support different media, bandwidths, and other Layer 1 and Layer 2 variations, the basic frame format and address scheme is the same for all varieties of the Ethernet. So this chapter examines the characteristics and operation of Ethernet as it has evolved from shared media, contention-based data, communications technology to today's high bandwidth, full duplex technology. Ethernet evolution. Since the creation of Ethernet in 1973, standards have evolved for specifying faster and more flexible versions of the technology. This ability of Ethernet to improve over time is one of the main reasons it has become so popular. Early versions of Ethernet were relatively slow at 10 Mbps. The latest versions of Ethernet operate at 10 gigabits per second and faster. Scroll through the timeline to view the various versions of Ethernet. At the data link layer, the frame structure is nearly identical for all speeds of Ethernet. The Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. Ethernet 2 is the Ethernet frame format used in TCP or IP networks. Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and the maximum is 1518 bytes. This includes all bytes from the destination MAC address field through the frame check sequence or the FCS field. The preamble field is not included when describing the size of a frame. Any frame less than 64 bytes in length is considered a collision fragment or runt frame and is automatically discarded by receiving stations. Frames with more than 1,500 bytes of data are considered jumbo or baby giant frames. If the size of a transmitted frame is less than the minimum or greater than the maximum, the receiver device drops the frame. Dropped frames are likely to be the result of collisions or other unwanted signals and are therefore considered invalid. So, Ethernet is the LAN technology today. It is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet standards define both the Layer 2 protocols and the Layer 1 technologies. For the Layer 2 protocols, as with all 802 IEEE standards, Ethernet relies on the two separate sublayers of the data link layer to operate: the logical link control, or the LLC, and the MAC sublayers. At the data link layer, the frame structure is nearly identical for all bandwidths of Ethernet. The Ethernet frame structure adds headers and trailers around the layer 3 PDU to encapsulate the message being sent. There are two styles of Ethernet framing: IEEE 802.3 Ethernet standards and the DIX Ethernet standard, which is now referred to Ethernet 2. The most significant difference between the two standards is the addition of a start frame delimiter SFD and the change of the type field to a length field in the 802.3. The Ethernet 2 is the Ethernet frame format used in TCP or IP networks. As an implementation of the IEEE 802.2 or 3 standards, the Ethernet frame provides MAC addressing and error checking. The Layer 2 addressing provided by Ethernet supports unicast, multicast, and broadcast communications. Ethernet uses the Address Resolution Protocol to determine the MAC addresses of destinations and map them against known IPv4 addresses. Each node on an IPv4 network has both a MAC address and an IPv4 address. The IP addresses are used to identify the original structure and final destination of the packet,